Okay, now as far as synthesis is concerned, we did a lot of synthesis, and we've in fact already covered a ton of synthesis in our review up to this point. But this question here is kind of cool because it involves an acetal formation, right? In the first step, you're going to take that carbonyl compound, this aldehyde here, and after step one, you would end up with this. You'd have one, two, three, and then you would have your acetal after the first step. Then what you would do is an SN2. So this forms the acetal. Then the next step you do an SN2. So the the acetylide would come in, do a nucleophilic attack on this carbon, which is electrophilic. So after that step, you'd end up with this. So you'd end up with one, there you go. You'd have your triple bond like that. And then in the end, you hydrolyze the whole dang thing. So all you do is burn so in the last step, so if I circle that in blue, you just hydrolyze the acetal. So you would break off the acetal and you would end up with an aldehyde. So you have an aldehyde and then you have the alkyne in there. And so you can see the answer is D, right? There's certainly no reason to have an alcohol in it, and there's no reason why you would have two alkynes in there. That's impossible. So that one's pretty straightforward, I think. Let's take a look at question number 4, which just says which combination of reagents would be able to synthesize this alcohol. So we have two methyl groups here, and then we have a propyl group over here. So if you just draw a quick bond line structure, the compound would look like this. You have an alcohol, methyl group, and then you have 1, 2, 3 for your propyl group, like that, okay? So in the first one, if you use the methyl magnesium bromide, sure, that's going to do a nucleophilic attack like this, but it's only going to add once. And so after an aqueous workup, what you would end up with in this case is you'd have 1, 2, 3, 4, 5. So you'd have 1, 2, 3, 4, 5 carbons. And then on this one, so you'd end up with 2 pentanol in that case. So that doesn't work. In the next one, you have the ethyl magnesium bromide. And yes, again, that would do a nucleophilic attack like this. But then you'd have 1, 2, 3, 4, 5, 6. So you have 1, 2, 3, 4, 5, 6 like this. And then you'd end up with this compound, which is 3-hexanol. So that's not right. The next one is using 2 equivalents of methyl magnesium bromide. And we've actually gone over this today. This is the reaction between a Grignard, and an ester. And remember that the Grignard adds twice in this case. So you would end up with losing this section as your leaving group, and you'd put 2 methyl groups in its case and get the alcohol, the tertiary alcohol. So that would be correct. And then the last one, you can clearly see that this one is wrong because the alcohol would be on the other side of the molecule. So that one would be incorrect as well. So the correct answer there is C. So make sure you review the reaction between an ester and a Grignard reagent, because remember, a Grignard reagent adds twice to an ester. Number 14, this one right here. Okay, wow, this is a cool compound. You've got a carboxylic acid, you've got a nitro meta to it, you've got a bromine para to it. They said which reaction sequence would make this. So if we just kind of walk through these out loud, in the first one, you would do a bromination. So you'd install a bromine over here. So far, so good. Then you would oxidize the methyl group to the carboxylic acid, also good. And then you would do a nitration. Well, this is an ortho-para director, and this is a meta director. But remember, this is a moderate deactivator. Or sorry, let me see here. So you put in the carboxylic acid. This is a moderate deactivator, but this is a meta director. So everything's going to direct to this position, and so you put the nitro group here. So A looks totally reasonable to me. In the second one, you would oxidize to the carboxylic acid in the first step. Then you'd put the bromine in the meta position. So this is just plain wrong. Then you would put a nitro group on it. So that wouldn't work. The next one, you've got a nitro group on there. I don't like that already, because then you would install the bromine, would go in the meta position. So that's not going to work either. Come on, pen. There we go. And the next one, You can't do a Friedel-Crafts with a strong electron withdrawing group like that, but even if you did, you'd have your methyl group, okay, like this. Then you would oxidize it to the carboxylic acid. And then these are both meta directors anyway, so then the bromine would go in this position. And so this isn't going to work and this isn't going to work. So A has to be the right answer in this case. And like one of the students was asking me, electrophilic aromatic substitution, you see that basically this question deals entirely with that pretty much. Let's see here. Question 15. Question 15. Which sequence of reagents would make this compound? So you want to put a chlorine and a propyl group meta to each other, but remember a chlorine is an ortho pair director and a propyl group is an ortho pair director, but we could have the ketone here, and then that would be a meta director. So maybe a Friedel-Crafts acylation is what we're looking for. So in the first one, we're doing an alkylation followed by a chlorination, but remember this would give us an ortho pair director, so that won't work. The next one is a chlorination. Again, that gives us an ortho pair director, so that won't work. This one is a contender because the first step is to do the Friedel-Crafts acylation, but then you do the reduction, which reduces it to a propyl group, which is an ortho pair director, so that won't work. Boy, the answer had better be D. Let's see here. So in the first step, we do the acylation. So in the first step, you would end up with this compound where you have the acyl group in the right position. Next step is going to be to chlorinate. That's going to go in the meta position. And then lastly, you would burn off the carbonyl with the Clemmensen reduction. And so, yeah, that would totally work. So D would be the correct answer in this case. So let me just get at my yellow highlighter. D is correct. And that's question 15. Question 18 says, predict the major product of this reaction. So the first step is just an oxidation of the methyl group. So in the first step, you end up with benzoic acid. Come on. In the first step, you end up with benzoic acid. Then you brominate. So that would go, this would go in the meta position. And then you do the thionyl chloride. So that would give you the acid chloride here. And then you treat it with methylamine. And that would displace the chlorine to give you the N-methyl like this. And so we look for that amide. Where is it? Oh, it's A. It's right here. Okay. So there you go. I would use my scratch paper for that one. I would just work the whole thing out and make sure I get the right answer, or so I can find the right answer. And last one, how do we make this compound? Good question. Well, we know we can't install the nitro first because it is a meta director. And this is also a meta director, but we could make that from, something like toluene, and which is, right, the methyl group is an ortho pair director, and then we could just oxidize it. So let's see here. First step, ethyl, using ethyl chloride. So that would make, that would give you ethyl benzene in the first step. Then you would nitrate it. So the nitro would go here. Then you use KMNO4 and that would oxidize it. Yeah, that looks reasonable, or it doesn't look unreasonable to me, I should say. So A looks good to me. In B, there's got to be a problem with B. First step is nitration. Second step is, so in the first step, you do a nitration, right? You put a nitro group in, but then if you try to brominate that, that's going to go in the meta position. So this isn't going to work. B won't work. If you look at C, again, first step is nitration. Then you try to do an alkylation. It won't even work because you get a strong electron withdrawing group. But even if it did, it would be in the wrong position. Next one, you oxidize. After this step, you end up with benzoic acid. But then you try to nitrate it. Well, that's going to go in the meta position. So the answer has to be A. It's the only one that's going to put our groups in the in the para position, respectively. Okay.